Hey everyone, welcome to Chapter 1, Section 1, Interval and Inequality Notation. So in this section, we're just going over how things are written down in terms of like domain or range. This section will mostly focus on domain, which is the set of all numbers on the x side, and the range is the set of all the numbers on the y side. Because as we get further along into the textbook, we will be writing domain and range for all those types of functions we'll cover. And so it's important to know how to express that and then the different ways people have expressed it in the past. So there's a couple different ways you can write it. The things that we're going to focus on are interval and inequality notation. So you'll see it written down differently, but it'll mean the same thing. So inequality notation is often combined with set builder notation. So an inequality is simply this part right here where it has the inequality signs. With these little brackets, this makes it set builder notation, and you will see inequality notation thrown in the set builder notation. I'm not sure why, but I will see the two grouped together like that. And then there's interval notation, which you won't see written inside of the set builder notation. And interval notation will look like this, where it just has a parentheses or a bracket. All right, so let me explain to you what this example means that I have right here. And so here I have -6 is less than x, and x is less than or equal to 1. What that means is the set of all real numbers x, such that x is greater than -6 but less than or equal to 1. So why did I just say that? That's part of the set builder notation. You see this first x. So that is saying the set of all real numbers x. That is this part. That is just this right there. And then such that is from this bar. So if you ever get into higher mathematics, you see things written down in set builder notation or various other forms of notation, and they'll have just a straight vertical bar, and they're trying to tell you something is such that something else. So that's all that bar means. The bar means such that. And then the rest of the sentence probably already makes sense to you. X is greater than -6 but less than or equal to 1. That's coming from this right here. All right? And that's exactly what this means as well. You can kind of briefly say this as x is in between -6 and 1. But it's important to know that x is can't touch -6, but you can touch 1 because it was greater than or equal to 1. So you would say something like x is greater than -6, but less than or equal to 1, just from reading that interval notation there. So what I did was I wrote down the different things you'll see for can touch versus can't touch. Brackets mean you can touch it, so brackets mean the or equal to part. Parentheses mean strictly greater than or strictly less than, meaning you can't touch it. And so you can touch it when you have the or equals to sign, the underline inequality signs, and then you can't touch it when you have just the strictly less than or strictly greater than inequality signs. If you're reading a number line graph, the solid dots indicate, these are two solid dots, that one's not solid. The solid dot indicates that you can touch it. An open circle or an open dot means you can't touch it. So it'll be, a less than or greater than kind of situation. And then these are infinity symbols. If you don't know what an infinity symbol looks like, it looks like a sideways 8. And you can never touch infinity. Negative infinity means it's just going to go left forever on the number line. Positive infinity means it's going to go right forever on the number line. So you can't touch forever. It's just going to keep going and going and going. All right? So anytime you have infinity symbols, they're always going to be written in parentheses or with your strictly less than or strictly greater than signs. And then the last thing to cover is your union symbols. and your union symbol is just this U, and it means an inclusive OR, meaning you can include the OR, meaning this says that x is in between -5, x is less than or equal to -5, or x is greater than 4, and so it means it's either or. Like, if one is true, then the whole thing is true. That's what it means to be an inclusive OR. So if you pick a number that's less than or equal to -5, then that makes that a true statement. If you pick a number that's greater than or equal to 4, that makes that a true statement. That's what it means to be an inclusive OR. All right? I hope that made sense. Now, let's just do a few examples. What we're going to do is I'm just going to convert these from inequality and interval notation, and then I'll graph it where I have an empty graph line. And yeah, that's pretty much what I'm going to do. So here I have two closed circles. So inequality notation will have the underlined symbols. And so if you see it going in the middle, where that means x is in between those values, that means you're going to have something written down like this where x is literally in between two different values, okay? So the inequality notation, the numbers are -2 and 4. So I'm going to write down -2 less than or equal to x less than or equal to 4. All right, they're both less than or equal to because x is falling in between them, reading it from left to right. But it does say that if you were to read this other way around, x is greater than or equal to -2, and x is less than or equal to 4 if you were to read it from the x's perspective. And since you will see the set builder notation with the inequality, I'm just going to write the little brackets and the x such that line. And I want to be clear that the such that line is not a 1, so I'm just going to like highlight it. All right. So yeah, that's that for that one. Interval notation, you can touch both those points, right? So interval notation is really short and sweet. Put a -2, comma, 4. That's it. Looking at the next example, I have an open dot at 175, and it's going left forever. So if it's going left forever, that means it's going less than 175. So I'll say x is less than 175. I don't even have to put the like negative infinity or whatever. You don't have to do that. That's because it's already known that if you just go left from 175, you're just going to keep going on and on and on to negative infinity. So yeah, just don't forget to say x such that, and then put your brackets. All right, and then in interval notation, that's where you'll have the infinity. You'll put a parentheses because you can't touch it, and then you'll put a 175, and you'll put another parentheses because that was an open dot at 175. All right. The next batch of examples, I'm going to write the domain in interval notation and then sketch the graph. So I'm giving you some in the inequality notation. We're just going to convert it over to interval. So this is not underlined, so I can't touch -2, but I can touch 10. So all I'm going to do is put parentheses -2, bracket +10. All right, so since x is in between those for your number line graph, you don't have to even do that sophisticated of a number line graph, like fill out all the numbers or whatever. Just put, I just want to see that you know when to put an open circle and when to put a closed circle, and then I want to see that you understand where you're going to shade. And so since x is in between -2 and 10, I'm going to shade in between those two values. And that's the graph for that one. On this one, x is greater than 7. So in interval notation, you're going to write 7. And then what's greater than 7 if you were to just keep going? Infinity. So it didn't say greater than or equal to, did it? So I'm just going to use a parentheses, and then you'll always have parentheses for infinity. This just occurred to me. A lot of times people will write 175, like going back to this one, sorry. 175 comma negative infinity. When you're ordering these things, you want to order them from least to greatest. And so if you had written down 175 comma negative infinity, that would technically be wrong even though you have the right idea, because it's out of order. Negative infinity is as small as you can go. So when I was writing this down, that made me think of that. So yeah, positive infinity will always go on the right, negative infinity will always go on the left, okay? So, or it always comes second, and then this will always come first, if you want to think of it like that as well. Back to this graph, if I'm just going less than 7, I just need to put a 7 somewhere on here in an open circle, and then just shade to the left, right? The arrow will point which way you're going to shade, so there we go. That's the graph for that one. And then these last couple ones, I'm giving you a sentence, and so we'll write it in inequality and interval notation just for the extra practice. So the set of all real numbers between -3 and 43, well, I'm between -3 and 43. So which one do I have to write down first? Inequality. So you're going to put x in between -3 and 43. You just got to determine, am I going to have, the symbols are always going to point to the left, sorry. And you just got to determine, am I going to have underlined inequality symbols or not? All right, you're never ever going to write something like this. You're never going to write -3 greater than x greater than 43. When x is written in the middle, it's always, the symbols are always going to be pointing to the left, all right? Now, it just said between -3 and 43, so it didn't say anything about or equal to -3 or equal to positive 43, so I'm going to leave those as is. I'm just going to write my x such that part and move on to the next answer type. All right, and then in interval notation, since I'm not touching -3 or 43, I'm literally just going to put -3 comma 43 and put them both in parentheses. So here I'm going to put -3 and here I'm going to put positive 43. They both have open circles, and since it said x is in between it, I'm going to shade in between it. So that's going to tell me I can pick any number in between -3 and 43. That's what the number line is supposed to be communicating. The last example here says the set of all integers, an integer is just a positive or negative whole number, the set of all integers greater than 10 and less than 80, or the set of all integers greater than or equal to 100. So there's kind of a lot going on here. So you have greater than 10, so x is greater than 10, but less than 80, which means it's going to fall in between 10 and 80. So I'm going to go back. I'm going to erase this. Sorry about that. So yeah, it's going to say 10 less than x. That's x is greater than 10, right? I almost started writing it down wrong. And then I'll write the 80. And it said or, so I'm going to do union, the set of all integers greater than or equal to 100. So I'll say x is greater than or equal to 100. All right? And so since it's interval notation, I'm going to put the set, inequality notation, sorry. I'm going to put the set builder stuff with it. So don't forget to do that. I just like to tack that on at the end. So yeah, it looks kind of weird, but that is the answer. Maybe it'll look like it'll make more sense in interval notation. You're in between -10 and 80. Or wait, was it positive 10 or negative 10? It was positive 10, sorry. So positive 10 and 80. And it didn't say anything or equal to, so they're both parentheses. You still have the union sign no matter what notation you're in. If it says or, put the union. The set of all integers greater than or equal to 100. So I'll just say that if I'm going greater than 100 and I'm not stopping, I'm going to infinity. So 100 is going to come first. And since it said or equal to, I put it in a bracket. And then I have my parentheses the positive infinity in parentheses, and that's always going to come second. All right, so those are the two different ways you can write it. Let's do the graph now. So I have 10 and 80, and it's in between those. And so I have open circles with shading in between. And then I'm going to move down the line, and I'm going to put 100, and I'm going to put that with a solid dot. And then I'm going to shade to the right, since the inequality symbol is pointing to the right. That indicates that I'm going greater than or equal to 100. And that's going to draw these notes to a close. So thank you for watching, and goodbye.